Good afternoon, everyone. Welcome to Lecture 4 for Automotive Packaging 450. Um, Today, we are going to start on Chapter 2. First thing, I want a couple things. I know that the homework was pushed back to Tuesday because of recording issues with Lecture 3. So I'm looking forward to reviewing everyone's homework. Again, you can always reach out to me with an email. You can set up separate office hours, or you can attend the office hours on Fridays at 4 Eastern Standard Time on the same Zoom link that's here. You can always join the live recordings. I'm trying to do live recordings every Tuesday, Wednesday, Thursday from 2 to 4 p.m. But if for some reason that changes, if my schedule changes and I'm going to just record it versus live, I will let you know. So keep that in mind. Again, so, first for the first chapter last week, we reviewed a history of automotive, how the manufacturing process has changed and revolutionized the industrial age, how packaging plays into automotive manufacturing, and some of the types of packaging, some of the material handling equipment that is used to carry the packaging to and forth from the plant to the line, how that returnable packaging or just packaging in general is used on the line for the operators to aid them in their jobs. So we talked about job aids besides packaging, and we also talked about how the returnables are picked up when they're empty and brought back, and how the quantities of what's put in the returnables ties in with the cycle time or the time that the material is used on the line, say by the hour, a couple hours, or by the shift. All that ties together so that they can have regular deliveries to the line and just deliver. The operator, just all they have to do is pull from their containers, and they don't have to really worry a whole lot about, is my material going to get here? Do I have to call for it and wait for it? A lot of things that are lean manufacturing concepts we spoke about, and those things keep the line running, because once again, one of the last things you ever want to do in automotive is to be responsible for line stoppages. With that being said, I wanted to go into Chapter 2, which covers returnable containers and program management as it relates to automotive packaging. So I'm going to share my screen. And I will go through this. So again, Chapter 2, there will be a homework assignment. I will be posting that very shortly. That will be due on Monday. Again, homeworks will be due on Monday. But questions, you have an opportunity to either join the live recordings, or you can get into the office hours on Friday. Alternately, you can reach out to me via email. So lots of opportunities and options. Again, I will try to be clear on things that are going to be in the homework, the assignments, which is what you'll be graded on for the course, for the remainder of the course, as well as if something is supplemental that I know is key. If you're going to be working in automotive packaging at some point in the future, some of these things you'll be able to either print out or be able to access later, and they are useful tools as you work. Okay, so Chapter 2. So this talks about program timing. So the big three, we'll talk about, people will say, GM, Ford, and Chrysler, even though we know Chrysler's now Stellantis, we still look at it in Detroit as Chrysler because that's what we know. So when you see this in here, it does take about, from start to finish, about 2 years to develop a vehicle. So that is from the concept. So if you ever go to an auto show and you see these concept cars, they will do clay models, and those models, clay and computer models, those will be transmitted into test vehicles, and then that will transition into production vehicles. There's a whole process on how that process works from beginning to end, but there are the people that work on the design side, and then there are engineers that working on all the details from standpoint of will these things will be able to manufacture the parts, will be able to manufacture the vehicle, who will supply those parts, What are the costs for those parts? Are the costs in line with what's been budgeted? Because the budget will be set at the beginning. So they're trying to stay on track. And then what are the manufacturing issues? Because many times some of the parts or the vehicles that are made, there will be parts that they look really good on a concept vehicle or on a drawing or a clay model, but there may be some issues with manufacturing for them. So it takes about 2 years to work through all that, work out all the kinks, and just deal with everything that's needed to get this car from an idea all the way to driving off of the showroom floor. So there are a lot of moving parts. It takes quite a while. Many of the companies, as they go through this process, they have program managers and they will meet regularly and go through the progress. So there are a lot of different ways they can do it. They will have usually charts for schedules to follow, what the due dates are and those kind of things. But they also, one of the big things they keep track of would be costing. So that's where they come in with KPIs. So you have 4 main KPIs. One would be direct costs. So what are the direct costs that you need to assemble a vehicle? This ties in with chapter 1 when I mentioned a lean manufacturing term, value add versus non-value added, right? So the parts and labor that are needed to assemble a vehicle, those are considered value added because they're directly going to building the vehicle. But then you have things that are also direct costs like transportation and finished vehicles that go outbound, the cost for that, those are also considered direct costs. Then you have indirect costs. So you have things that are not directly related to the manufacturing of that vehicle, which you'll also hear a term non-value added. And some things that tie into that would be utility charges, things that relate to maintenance, like PM, preventive maintenance, or just maintenance for repairs for lines that are down, taxes. When they talk about the value add versus non-value add, so I'm bringing this up because they don't correlate exactly with each other. So some of the direct costs dealing with parts and labor, those may not go right on the car, but it does help to build the car. So from a manufacturing and an accounting standpoint, when they talk about direct costs, they're talking about the accounting terms for direct costs and indirect costs. And then you've got investments that the program will make. So there may be equipment that they need to buy, some, lines, conveyors, heavy equipment that's needed for that. But then you also have investments that are related to the packaging. So if you buy returnable containers, then that is considered an asset. So even if a company is buying these, that would be the exact same thing as purchasing a long conveyor line. So from an accounting book standpoint, those are all considered assets and investments. Another thing that is important that the teams keep track of during the development of a vehicle and the launch of the vehicle and the program, they're looking at things like weight of the parts because they have to meet certain standards for fuel economy. So this is something that they have to track throughout the life of building and designing and this vehicle from that concept all the way through. See, another thing here, we talk about the, I mentioned before, we have the project management process. So you will, as you're working, some of you may have done this or you're working towards it. PMP, which is program managers certification, they have a lot of knowledge and they actually go through courses and they take a certification exam to become a PMP. And that means that they are qualified to run projects or programs. A program would be a group of projects, which is why we would call a vehicle launch a program, because they have many, many projects to tie together. The project manager or the program manager is making sure all these balls are kept in the air and they're working together on time, meet the schedules, meet the budget, and they actually deliver what they said they're going to deliver. So when you talk about the program management process, there are 5 different milestones. So I'll go through that later this week, but there are 5, and it starts off with like basically initiation, ideation of the product or whatever that vehicle is, all the way to launch and full-scale production. So they break that out into 5 parts, and they will have gates and points that they have checkpoints where they say, are we on track? What things do we need to tweak? You know, what departments need help? Which things are going the way they need to go? What are some things that aren't going in the direction that we needed, that we thought it was going to go? And do we need to shift gears and go back where we were, and how do we get there? Or is it something that we need to actually change the gears of the direction that we're going for this project to meet our final goals? So it talks about these milestones. So you've got pilot builds, and you've got launches. So these are checkpoints where you get in, just like we have someone joining. Okay, so you get the you get these builds where it's basically a test run. Hi, Brandon, welcome to lecture 4. You have builds and phases, and these builds are basically checkpoints. And you're doing prototype testing, or you're doing small production runs of the parts or the vehicles. And that's a checkpoint to just make sure everything is on track. And that gives people the chance to make adjustments to whatever the product is or the packaging. And they may also use this to be an approval point. So if everything passes whatever test it is at a particular phase, then they're ready to move to the next phase. Okay, so when you talk about this whole pilot process, you start off by, again, doing these prototype builds. So you just might build one vehicle at a time. So that goes back to originally what we saw where with Henry Ford, where they show in the very beginning of chapter 1, they were building, one person would build one vehicle, right? So this goes back similar to that, because you're just building one vehicle just to see, do things fit together? You know, what issues are we encountering? You know, things like that. How is this going to look along the production line? Because they will send that car down each station of the production line and look for issues in each station. At this point, regarding packaging, many times what should happen is that the packaging should already be planned out and expected. What many times happens is they just ship it in a corrugated box and say, we'll worry about that later. But as a packaging engineer, I'm going to stress to you that at this point, you want to be involved in these build events as often as possible, because that is one of your chances to see, is the packaging working? So if you can get parts in packaging, even if it's a prototype pack, so you can see what it looks like, see what the part looks like. Is it shipped safely? Is it in good condition? Then can the operators pull the part out of the line and out of the packaging and use it on the line without an issue? Other things you want to look at would be, do you have any issues with if this is returnable or expendable? You want to see, you know, what does this look like? Then also, where on the line is this pack going to be used? So you want to know, do they have a lot of space on the line? And if you have something that's a bulk pack, are they going to have room for it? Because I've been in plants where we have production, the pilot builds, and they will have room for a small tote instead of a full pack. And they maybe they're big parts. And you know that there's not enough room allotted for those parts. So that's why I say you want to get involved early on as soon as you can, because if you don't, you may end up with some packaging that you don't like, and it would be really difficult to work with it at that point. Okay, so I mentioned the 5 phases that they have during this program management process. And the first one is phase 0. So this is the ideation phase. So you have everything's high level. They say, okay, we're going to make a new Cadillac SUV, and it's going to be electric vehicle, and it's gonna, have really big wheels, and we want it to look this way. And it's gonna have we're gonna use a platform based on a Chevy truck or whatever. So they'll say that, we know we want to use the frame of this, and we're going to have the interior look like some other vehicle. So that's kind of where it is. It's more discussion, more pie in the sky, general conversation. And they may be getting, drawings from the design studio, but it's really, really early on. So they will do some very rough estimates of, how much do we think it's going to cost? Is it going to cost to build the vehicle? How much is it going to cost to get the equipment that we need? Are we going to be leveraging existing equipment and existing platforms, or are we going to be building something brand new? Those things will impact the cost. Most of the time at this point, you're looking at the program management team and you're looking at the finance team. But I would personally recommend that the packaging engineering team gets involved. And if you're doing automotive packaging and you have standards, that's one of the reasons why I mentioned it last week during the lecture, that you want to have standards set, because when you do, it's much easier. So if they say that they're going to be following the, the platform of, XYZ vehicle, and you've got the packaging standards already for that existing vehicle. When they say they're going to pull, the chassis from this one, but the interior of that one, you could actually pull your packaging and see what your packaging looks like, and tell them based on the number of vehicles you think you're going to sell, because at this point, this is something that program management and finance would be using. They would say, think we're going to sell 1 million of these over a 5-year period, or 300,000 a year, whatever. They will have some estimate. You can take your previous information, maybe they used it for 500,000 vehicles. So if they say they're going to double it, you can say, okay, I'm going to need twice the amount of packaging, for example. You can estimate it. And the reason why I suggest being involved in phase 0 and using your best guess estimates based on existing previous programs is because it can have an impact. So many times, if you're building an automobile, they're spending millions of dollars on the returnable packaging alone for any program at any given time. If you're a tier supplier and you're supplying, a certain part of the vehicle, you're easily spending $300,000 to maybe $1 million on packaging, returnable packaging for a new program. So you want to make sure that that money is set aside and ahead of time. Sometimes what happens, just so you know, if you're going to be an automotive, when they have these conversations in phase 0, they'll put in a number for packaging. And I've seen it where other departments will pull that money. You won't even know it's in there from a packaging department standpoint. They'll say this money hasn't been spent yet, because packaging is usually one of the last departments to actually use whatever money's been set aside. So sometimes you get a department that needs conveyor equipment and they don't quite have enough money because they underestimate it. So they will take the money from the pool of packaging because it hasn't been used yet, because it's not time to buy packaging. So just be aware of those things. And then by the time it is time to buy packaging, you might be short and you may not have enough money to buy all the packaging that you need. And that's a whole different issue right there. We won't even talk about it right now, but we will talk about that later. The next phase is pilot phase 1. So I mentioned the pilot. So these pilot phases or builds, they are used as test cases. You want to see, how are things running? Will they work? What does it look like? How is the assembly plant going to handle it? And they will also look to see, is this something that's even buildable? So can we make a truck that's luxury, that's EV, that will also can turn into a boat, just making up something. So, you know, the first phase, they've said, yeah, that maybe we could do that. And then they say it's going to cost us this much to get this equipment. Phase one for the pilot, then they're going to start actually validating design. So I mentioned before, they already have a list of parts that are going to carry over. Carry over is going to be, we're going to pull from an existing vehicle, and we're going to use all those same parts from that same transmission or that same wheel assembly or the same seats or whatever it is we're going to use, or the same engine. They can pull that over and say, yeah, we've already done it. Now we need to focus on the new parts of this vehicle. Sometimes they'll need things like tooling. So that will come into play. And that's something from a packaging standpoint. You need to understand, which of your packs are things that you can buy off the shelf. Which things do you have that packaging, maybe you have an off the shelf bin, but you're going to need dunnage that goes in it that's custom. So, those are some of the things that you need to look at. And are you going to require tooling? You're going to have dunnage that's going to require tooling. So if you put a foam insert in here, for example, are you using a foam that's cut and fabricated to shape, or are you using foam that requires tooling and a mold for it? So if you require tooling and a mold for it, that's going to add to your budget. So those are things that you need to look at. When they do these at this pilot phase one, when they start doing builds, they're, like I said, they're very slow. This says even here, they're building, either individual ones, they may do 20 or 25 at this point, but it's still really, really early, because a lot of times at this phase, some of the suppliers haven't even been determined, or they may not have signed contracts. They may have an idea of, we're going to use the same engine for this new vehicle, but the engine supplier has not signed a contract. So it's still an assumption. Most likely they will end up using that supplier, but if they haven't signed a contract, there's no guarantee. And there's certain things that the supplier won't or can't do because they don't have a contract yet. So that's why you're still in somewhat of concept in a pilot phase at this point. And suppliers aren't selected. This you'll see suppliers shipping the parts in corrugated versus any returnable packs. But at this point, you can start figuring out which ones you think are going to be returnables and which ones are going to be expendables. Again, you won't know for sure, because if the assumption is you're going to use the same engine plant, and that engine plant is always using returnable racks, then you can assume there's going to be returnable racks. But if for some reason there's some change in the contract, or maybe that supplier ends up being at full capacity and they can't do it, and they're going to have to source another supplier, then you're going to have to determine whether or not the new supplier meets the criteria for a returnable pack versus an expendable one. Okay, Brandon, do you have any questions while I am going through this?
No, I'm all good.
Okay, great. So again, they want to protect the parts. They're usually going to try to ship it in expendable packaging. But if you can get returnable containers for suppliers that are going to be returnable suppliers at this point, you should do it whenever possible, even if it's a prototype. You want to try to get the packaging at every phase as close to, technically you don't have to, but you want to get it as close to what production would be. The earlier you can do this, the earlier you can get things signed off, the earlier you are done, and you don't have to worry about fighting fires at the end. We'll talk about that later, but you can take the time that you would normally have used to fight fires and fix things at launch, you can actually devote to developing more innovative packaging and saving money before you even start. Okay, so then you move to the pilot phase 3. This, where some of these previous pilot runs were not done on the line exactly where they were planning to do it. This is getting a little bit closer to that. So each time you have a pilot build, you're looking, every time you have a new phase, you're getting closer and closer to doing test runs that look closer to production. This one, we were talking about, building 1, then building 20 or 25. Now you're looking at building less than 200. A lot of these vehicles that are built at this point, they are probably going to go to different departments. They may go to specific dealers that are known to get early vehicles that would get feedback. These may also go to certain customers that they want to get feedback from. So, usually these 200 either are, they're going somewhere specific. They're not just going to throw them away, but they want to get feedback. So I think I've even seen some of them going to auto shows. So, these are just some of the things that they look for. So these, they want them to look pristine because they're usually going to be going somewhere to sell. Look at this new vehicle, look what we're going to do, early, hot off the presses, these are the secret vehicles that we want you to see. But from the production side and from the packaging side, now you're looking at parts that are getting closer to production. So they're generally considered to be production parts, but there still may be some tweaks. One of the things that you'll notice in automotive is that the parts are very dynamic. So especially for something new, every time they go out onto production line and do a pilot build, they learn something new and they may have to make some changes. So one of the challenges that I've seen, so keep this in mind, one of the challenges I've seen is that from a packaging standpoint, you might be waiting for the final product, a drawing or a sample, and it may be really hard to get certain parts because they'll change them up until the final production launch. So when they're ready for final production, you may not see it until then. But then that makes it really hard to design packaging for it, because if you don't really know what that part, they may have put a metal clip on a plastic part and that metal clip now protrudes. So now instead of getting 10 parts in a pack, now you're only getting 8, but you don't really know that until the end. So these are just things that you want to ask a lot of questions. You want to also become really close to your engineers, because the part engineers, product engineers, you want to get to know them very well, and you want them to feel comfortable enough to let you know, hey, we're making a change to this part. We don't think it's a big deal, but we just want to let you know anyway. Probably won't affect packaging, but we're letting you know just in case, because many times they'll think it doesn't affect the packaging, but it could. So you want to know your product engineers, your part engineers pretty well as you work with them. So here, it says that in phase 2, you've got things like racks and returnable containers that come in. These are going to be many times either prototypes, or they're going to be maybe hand-built ones. So they're going to be close to production, but the process to make one could be a lot different than the process to make them online. To build, the process to make one by hand is a lot different for a rack than if you're going to build 500 racks. So just keep that in mind, that some things, they'll be very similar, but there may be some things that change. But again, as you go through this process, you're collecting all that information, understanding how the packaging is working on the production line, how well is protecting your pack, how it's shipping in, how does it fit in the space that is available at the line for that part. So you want to look at all those things throughout every single time there's a production run, and you can get products in packaging that is as close to production as possible. You want to be involved in it. Again, you're looking at some of the packaging is going to require tooling. So let's say you have an injection molded tote or some injection molded dunnage, for example. You have to keep that in mind, because if you have parts that are injection molded going into an injection molded pack, the timing is the same for any injection molded part. Doesn't matter if it's packaging or if it's an actual automotive part. Sometimes this is another reason why it's important to get to know your automotive product engineer, your part engineer, because they just think that sometimes they're only so focused on the product, they don't realize that the packaging timeline is the same. It takes as long. They think that they are going to get their product in at the last minute, and then the packaging will be available. So you want to definitely keep in touch with your product engineers. Okay, so again, for phase 3, these are built at the assembly line, and now you're testing this to see how does this work on the line with the line workers. So it's more, looking at, what this is going to look like when you're in production. You may not have tooling, you may have prototype tooling, but you won't have the full scale tooling yet because you haven't necessarily signed off on the packaging. So remember that. That's why I was saying it's important to understand the timing of the parts, because if you need to kick off some tooling for your packaging, you need to do that well ahead of time so that your packaging comes in time for production. Okay, when you get to phase 4, this will be like your final opportunity to test. So they're testing the product, they're getting closer and closer to production, but you're not done. And so this says this is done 6 weeks for mass production. That's the guideline, but it may happen before that. It may have to happen after that. It just depends on the company and part availability and things like that. So this is saying, you're during the run, you have the people on the line, they're given extra time to do this build because they're expected to look at this and kind of, we want to see how does it work and how do we work out the kinks. So this is important because they're trying to run as close to speed as they can, and what the line's going to look like and what things are needed to get it to run. Okay, this is saying, at this point, the racks and returnable containers should be built with production tooling, and whatever processes they're using to build that packaging. So this means that by phase 4, you probably need to sign off on the packaging, because there's a whole process of signing off, and once it's signed off, then purchasing can order it. So the packaging can be ordered until packaging signs off on it, but it's hard for you to sign off on it if you haven't had any opportunity to run the packaging during any of these production runs. So it's hard. You want to make sure that you're seeing, at the very least, understand which of your products are going to be new, which packaging is going to be different, and those are the ones you want to focus on. So if you're taking the same engine, leveraging the same packaging, it's not as big of a deal. But if you've made changes on the engine, you're going from like a 4-cylinder straight, 4-cylinder to like a V6 engine, you're going to have to look at all new packaging, keep those things in mind. See, phase 5, now what you're looking at is actually full-scale production. So phase 4, you're spending a lot of time, with launch, working out the kinks. It can be very hectic. From a packaging standpoint, if you've not had the opportunity to be involved from phase 0 and phase 1, you might be getting packaging in and packaging that you would never have planned for, you wouldn't have picked it anyway. But if you've gotten involved with the program team, with your engineers that are doing the parts, and you're at the production builds, and you're in touch with the suppliers, working with them, you can actually work on the launch where everything's coming in. And from a packaging standpoint, you should be able to sign off and say, yes, these arrived, they've been tested, I know they're going to work, they've been run during phase 4 at a production rate, and we know that they're working and they fit where they're supposed to fit. the operators can pull from the parts from the pack sufficiently, and the packaging protects the parts during shipment. So those are some of the things that you want to look at. So at phase 5, you've already had everything brought in. At phase 4, the packaging comes in, and phase 5, you're just looking at how are things running. Do we still have enough returnables? Are we losing returnables? Why would that be? And really management of those returnables, and then looking at looking forward for new vehicles. What are some innovations for future vehicles related to packaging that you can look at and start implementing. So that is really what you want to kind of shoot for. However, in reality, it may not happen that way. So that's where the standards and organization come in handy. Okay. Okay, so program cost. So these are some things I'm going to go into and give you some more examples later. But when we talk about the program cost, we have a new program for a vehicle, and you might have 60 different rack designs. So remember, we talked about the fact that when you look on the line, you're going to see mostly things like totes and bins, and that's what you see mostly. So the number of bins and totes that you see online will be higher from a standpoint if you count them. So you might count 100 totes, but you may only count 10 racks. But the racks take up a lot more space than totes or bins would. So you want to also look at your racks, because the racks are very expensive. They require more maintenance if they're not taken care of properly. So if, for example, you have a metal rack and you store it outside in the rain, in the snow, those racks aren't going to work as well. Or maybe the racks are picked up by inexperienced fork truck drivers. And those fork truck drivers, when they bring those racks in, when they bring parts in, they hit the top of the rack on the door coming in or out of the truck or even the building. That can damage those racks, and those racks won't last as long. So it's important to understand, how the racks are handled, where they're going to be stored, what's going on the racks, so you can, one, protect the product that the racks are going to be transporting, but then also understanding how these racks are going to be handled, because that will tell you, do you need to maybe beef up the racks and make them extra strong, or are, lightweight racks good enough? Are they going by rail? Are they shipping by truck? What are some of the transportation environments that these racks will be handling? And, if you're handling a rack if you're dealing with a rack that's going to be holding glass windshields, for example, that's going to be a totally different, you're going to have some totally different things with design than if you have, say, a transmission that's on a rack, heavier product. So you're looking at things like, will these transmissions weigh out or go to the maximum weight of the truck for shipment? And we are limited to the number of racks we can put on because the truck is now overweight, versus windshield racks that are going to be carrying glass parts that may break. So you're going to have really two different design concepts when you build racks like that. Some of the racks are used for work in process. So work in process is going to be something that rack maybe stays within the building. It's not necessarily going to be shipped out. This just gives you here, an idea of some of the types of racks that you might have, as well as bins and totes. So once you know that, you have to have a list of all the parts. And once you know all your parts for that vehicle, which that can be ever changing, but you should be able to get a decent list in one of the early phases of what it is. A few parts may change, but for the most part, they should be able to give you a list of what type of parts are going into the car. So trying to think of an example. Let's just say this computer mouse, right? You know that you're going to have a door for your battery. You're also going to have an outer casing. You're going to have different buttons and feet on it. You're going to have, you know, something, a mouse wheel. But some of the things that may change, it might be, you know, what type of mouse wheel you're using on this. Are you going to have a solid design? Or you're going to have a colored design? So those things might change, but if you were to take this apart, part by part, you might end up with 50 parts. So you can get a part list to say, you know, wheel, feet, on and off button, door, you know, all those things. It might change a little bit, like I said, to say, this is going to be a blue wheel versus a red wheel or a white wheel, but it's still a wheel. So that's important for you to know as you're designing the vehicle packaging. How many parts you're going to have? Are you going to have roughly, you know, 6,000 parts? You're going to have roughly 300 parts. You know, what are you going to have? So that will help you to determine, I'm going to need, you know, 300 different packs. Now you may end up using, you know, the same standard bin for 50 of those parts, and then your dunnage may be different, or how many parts go in there, but it can help you plan to say, you know, out of my 500 parts for this particular product, or 1,000 parts for a product, I'm going to put 50 of them in the standard bin. And then I'm going to put, you know, another 50 in a certain type of tote. And then, you know, 150 of them are going to go on a rack, those sorts of things. So you want to really kind of start fleshing out what you're going to use, and it may change, but you want to have an idea, because at this point you want to help the program understand what the cost is going to be. Because if they don't know what the cost is, then it will cause the program to not, you know, have the right cost of the vehicle. The packaging could make a vehicle profitable or unprofitable. Generally, it doesn't happen, but it is possible to happen. I can give you one example. I work for a vehicle-like company, and I may have mentioned this before, but the company, they had not really tracked their packaging, returnable packaging. When I came in there and I estimated and calculated based on a fleet calculation, which we'll be going through, I calculated that they were going to spend $600,000 on certain packaging. And they said, well, that seems like that's too much. So they set aside, I think, 300,000 for packaging, 325, whatever. They basically had said half. Everyone calls half of that. And that's what they thought they were spending. But what they didn't know was that the supplier would buy 300,000, for example, but then the supplier knew that they weren't going to have enough, and they would just bring more in, and the company would just pay for it, and they weren't paying attention to it because it wasn't put into the beginning of the program. So for this particular program, you know, I given them some things to track earlier, and I told them it would be $600,000. And when they actually went to purchase it, it came out to about $600,000. And they were like, huh, we didn't know we were spending this much on packaging. So it's really important that you can estimate the cost. So here I highlighted here, a fleet of racks and containers, you know, estimating that cost begins during pilot phase 1. And it's used as part of the return on investment calculation, which we'll work on, and we'll talk about that. But the reason why estimating that cost starts early is because, as I mentioned earlier, as you're talking about the early phases, in phase 0, when I said the finance and program management team is estimating the costs, if you don't give them any cost or timetables, they'll make up something for packaging, because they have line items for packaging and they'll fit in what they think. So the example I gave you, in the past, their cost and finance team would just put in $300,000 if that's what they were estimating. But as a packaging engineer, you can get much better estimates, and you can get more defined estimates. So when you go through phase 1 and they start giving estimates, they may not even ask you for it. You can submit it and say, hi finance, hi program management. I understand you're working on this new vehicle. You're in phase one. I've estimated that the cost for the packaging is going to be $1 million. So they can plug that in there and it's a good placeholder for them. And as you do more and more programs, you'll be able to get more and more detail and get closer to, what you think the cost will be. I mentioned here, one of the ways they can estimate the cost is they can compare that packaging to a similar design. So when I mentioned, yeah, this program is going to use the same engine, or they may use the same seating, or they may use the same chassis, or they may use the same truck bed or whatever, they can take, okay, we spent this much for it before, for 300,000 of them. This program is going to have twice as many. So we can probably automatically we'll double the number of packages we're going to have for that one, because it's going to use twice as many, but also you can look at, has the pricing changed for this packaging? So, we've had a lot of price increases during the pandemic. So you've had injection motor parts, and we had issues, we're still having issues with getting resin and oil. So the price of this may have gone up. So when you had the one program before the pandemic, this tote maybe costs, I'm just going to make up a number. Let's just say it costs $100 per tote. Now, after the pandemic, with the shortages, supply chain backups, and issues with oil reserves and resins and all those sorts of things, this may now cost $175. So you can keep that in mind with your estimate, but you can take the similar design for something. And even if you have a windshield, let's say, you're going to have a windshield. Well, this windshield, it won't be exactly the same as the last truck, but it's going to be very similar. So you can, pretty much estimate that, the windshield is going to be around the same size. It might be slightly different shape or slightly different curve, but the windshield for a truck is always going to be very similar, versus, say, if you're taking a windshield for a truck versus a windshield for a sports car or sedan or something like that. So, you can do something like that. So there are, click on the link for IntelliCosting, but there are companies that do what's called forensic costing. And what they can do is they can tear down like a competitor's product. And from that, you can kind of estimate, oh, wait, because a lot of the automotive companies, they share the same suppliers. So underneath the hood, there are an amazing number of parts that are similar underneath the hood that you wouldn't see, or inside, behind the dashboard, or inside the seats, or in the steering wheel. Just airbags, for example. Airbags are only made by a couple companies. So if you've heard about airbags being recalled, and you hear it's happening with this OEM, that OEM, all these different OEMs are having airbag issues. A few years ago, it's because all of the airbags were coming from that same supplier. So they were all receiving defective airbags from that airbag supplier. So that would be one example. So sometimes you can look at a competitor's product and packaging, because it's going to be very similar to yours. Okay, so then this talks about like how you can take that cost estimate and then start looking for suppliers. Because one of the reasons why that estimate's done, it's basically a budget, like you're budgeting at home, you're budgeting and say, okay, I have this budget. I estimate it's going to cost me this much. It's going to cost me $500 a month on groceries, right? So you kind of plan your budget, and you might shop at, grocery store A because you spend $450 on groceries. But then if you go to a Frou Mart and buy all the organic stuff, and you weren't planning on buying organic, because when you budgeted for a regular orange versus an organic orange, it helps you stay on track. So if you decide that, eating high-end organic products that is part of your plan for your health, for example, then, and you build a budget for that, you can stay on track. But if you didn't plan on that and decide that you're going to spend, you're going to overspend. So it's the exact same thing with the auto companies. So they're looking at, how do they budget? What is their vision on what this product's going to be? Once you know the vision on this product, so let's say if you have some high-end luxury vehicle, many parts for this, because it's such a high-end vehicle, you're going to have probably a lot more surfaces that would be class A that can't be scratched. They have to look really good. They have to stay clean. So that might be a priority versus, if you have some SUV that's off-road that people know they're going to get it dirty, they're not necessarily worried about it looking pristine. It's not necessarily, they're not looking at it from a standpoint of, how is this vehicle going to look a year from now? However, they would be more concerned, and what's most important for them, a priority is going to be, the chassis, the frame, the suspension, how does this handle the tires? Those are some things that they're going to look at for that vehicle. So these are just some of the things you want to keep in mind as you start working on your budget. Then you start determining, who's going to supply your packaging, and then how are they going to build it? So in automotive, when they have this process for determining the cost, sometimes some companies will have bid reviews. So they will have potential suppliers put in bids. So they'll give them the requirements. So I mentioned before, is it a windshield, or is it a chassis, is it a frame, or, what are these parts and what are the requirements for shipping, for line side display, for cleanliness, just whatever your list of criteria might be, that has to go into your list for the bid. So then they have to take whatever your criteria is for your packaging, size, weight, material, whatever you might determine your criteria to be, and then it will go into a bid review. So this example gives fabricators. So the fabricators are the companies that make racks. So a lot of times when you hear in automotive packaging, when they talk about fabricators, they're generally, talking about fabricators of racks, because these are welded together. And the shops that make these, it's probably closer to what people consider fabricating versus an injection molded bin or hand cut foam or something like that. Sorry, there's a fly in here. Okay. So this mentions bidders posting a price on an auction website. Some of the OEMs do that, and other ones don't. So it depends on what it is. It kind of goes in phases on how purchasing works. So purchasing, they will go through times when they want things posted on a website and they want auctions. Other times they want face-to-face bidding for quotes. Sometimes they want everyone in the same room when they're doing the bidding. Sometimes they don't want anyone to know who else is bidding against them. So it really depends on the OEM, the time, the economy, a lot of things go into that. But either way, this part is important. The lowest bid wins. So in automotive, no matter what the bidding process is, usually the lowest bid wins. Every once in a while, you might get a supplier that purchasing has selected because they were towards the, they were maybe in the middle, but it may be because they have a long-term relationship, it may be distance. So it might cost a little bit more, but from a standpoint of logistics and supply chain for returnables, for example, they're spending less on freight. So really in the end, it is the lowest cost, but there's a lot that goes into it. Okay, so when you're designing racks, yeah, this is true. You're going through the whole prototype, build, design, testing process. It can cost about $12,000, probably more than that at this point for one design. So this one on average for a vehicle, new vehicle launch, an OEM, it's probably going to have about 60 different designs that will require racks. And so now they're looking at almost $750,000 just for the design fees for that rack. Then, yeah, you are going to spend about $1,500 per rack. So a rack like this, a rack that has, you know, this type of dunnage in it, or any kind of dunnage, any rack is probably going to cost you about 15. You can just do an estimate. So when you're doing that phase 0 packaging estimate for the finance and program management team, and you get a rough estimate of how many racks you need, just multiply that by $1,500 to get your cost for the budget for the racks. So this is true. When you look at this for an OEM and any new vehicle, they're going to spend probably around $40–50 million just for the racks. That's pretty accurate. Okay, so we mentioned before about racks taking up so much room on trucks. I think it was like 60% of the volume on the truck is taken up. You know, the most 60% of the trucks that come in shipping packaging will be shipping racks. So when it's time to order, I mentioned like phase 4 where you're launching, you know, by this time you've had the packaging tested, you've done test runs, and then you get to the point where you approve it and you start ordering it, and then the racks start coming in. And this is to, you know, we want them to start coming in right before launch so that you can make sure that everything works. But the supplier, for one, can't build all the racks that you need. Because let's say that you end up, you know, that you need a fleet of 1,000 racks. I'm just going to make up a number. You need 1,000 racks. Couple issues with that. The fabricator or fabricators, because a lot of times I'll have multiple people making the racks, they cannot make 1,000 racks at one time. It just takes time to make those because they're welding those. There's a lot of manual labor to put those together. Another thing is, sorry about the fly, he's still here. I might have to spray him. So if you see me spray, don't laugh. Okay, so the racks they cannot be built all at once. They probably can't be built by just one supplier. Like I said, they're welded, there's a lot of manual labor. The other thing is that if they could build all these 1,000 racks at once, where are they gonna go? They're not gonna fit in the building. So in the last homework assignment, we talked about how much space is required just for one day's worth of material, okay? So they have, I think, 400 trucks coming in for material every day. So just imagine with that, you're also bringing in 1,000 extra racks. They just can't handle that. They don't have the room for it. So what they generally tend to do is say, okay, we know we're going to use 30 racks a day. I'm just making up a number, okay? 30 racks come in a day. So what they do is they say, okay, we want to get, you know, let's say we're going to get 90 in. Let's say we get 100 in, right? So they start off basically, you know, with 3 days worth ahead of time, or they get a week's worth. They get maybe 150 racks because let's say they use 30 a day. And then to get up to that 1,000, they'll start bringing in enough for each day. So then they'll get those in the system and they're getting filled and used. So they're on trucks and they're shipping and they're being used in production. And then as they need more, they'll bring those in. So they'll kind of meter in how many they need for production until they're up to full scale production. And then those racks are all being used. They're all in play. They're all being, you know, either transported with parts or transported back empty to get filled with parts again. But it's that loop. So that loop is smoothly running and that loop is completely full of product and racks. So I hope that explains how they fill up the supply chain, the loop for returnables. You have any questions, Brandon?
Okay, so this is especially with racks and everything, they're one of the things that get pre-filled weeks in advance. Has there ever been an issue with because pandemic came about and disrupted our supply chain majorly. So what did that look like for these racks, considering they're like, did those end up staying in there for like a longer period of time? I know that had to be kind of weird.
So we are still seeing a delay in automotive,
Oh,
the supply chain. So a lot of things happened in the supply chain in general. So I haven't heard about it lately, but I know it's still an issue. There were boats sitting on out in the ocean, like on the Pacific Ocean. Like if you were to go to California, you would see boats sitting out in the ocean that were full of material that needed to come back in that hadn't been brought to the port yet because they had a backup. So they had a backup at the US ports because of labor, right? They had to shut down and they had labor. So then for them to catch up, that takes a while. But then you had the disruptions overseas as well. So there were a lot of disruptions there. And then we had other labor disruptions. So, just statewide, stateside, domestically, we had shipments that were delayed because either we didn't have enough people, we didn't have drivers, or one of the other things, we had a couple things that happened. So there were just so many domino effects that happened. So we had a shortage of drivers, but then we had people that they had trucks, but they had the tractor trailer, but they didn't actually have the box part of the truck. So whether it was a sea container or a trailer, those weren't available because they were sitting at docks or sitting at ports or sitting somewhere in a building. So they were either full of material, and those containers hadn't been emptied, or they were empty and there's no driver to go pick them up. So then you had shortages of transportation to move the parts. On top of all that, we still have a chip shortage. So we have people that are building vehicles, but they can't ship those vehicles out to be sold because they don't have the chips in them that they need. Now, automotive has always been a big purchaser of chips, but when the pandemic hit and they shut things down, they lost their priority space in line. So the few chips that were available, other companies, other industries, they moved up to the top of the food chain. So then when
mm-hmm.
automotive started ramping up, the chip suppliers were saying, it's going to take us a while to get those. We are behind, we have a shortage, and we just can't just give you chips. So they kind of lost their place in line for the chips that were available.
Mm-hmm.
So we still are seeing a chip shortage. So a lot of things have slowed it down. So when you hear about I don't know if anyone's tried to buy a car lately, or have you heard about it, Brandon, that there are chip shortages and the cost of cars is pretty expensive right now.
I believe GM is one that has a lot of chip shortages right now, right?
Mm-hmm. Yes.
Yeah.
So the cars that are available with chips, they're in high demand. And then you have cars that are still waiting for chips.
Gotcha.
So when we used to watch that Ford video, and they talked about, pulling something off the line if there's an issue, they can do that, but they don't like to do that. But with the pandemic, a lot of that has to happen where instead of it going out the door and ready to be shipped and ready to be sold, it might go into some queue line or in a lot or somewhere that someone's going to have to go back and put those chips in.
Gotcha.
Okay. All right. So, like I said, I talked about the plan to build enough racks and like when to deliver them. So again, I mentioned some of the things that are important to know: how many racks are required for the entire program, how many fabricators are available to build them, so they do this bidding war, and I said, mentioned that, the lowest bidder usually wins, but they usually end up picking a couple of companies that have the lowest bids, because not just one company can make them. I mentioned the capacity. So, and they look at it in racks delivered per week. So they're looking at, yeah, make 30 a day, but we need 150 a week. So that's what they're going to meter in. That target price is important. So that's already kind of been, fleshed out with the bidding from purchasing. Proximity. So when they want rack suppliers that are close by, because that freight cost adds up. And especially now, the cost of freight is pretty high, and that can have a significant impact on the price of what is being shipped to them. And then one of the other things they look at is quality and delivery performance for each fabricator. So there's a whole scoring system in automotive where they will score the supplier based on their quality, their service, availability, cost, issues. They'll look at issues, and when they have a problem or defect, they have to go through a whole process of root causing out what the defect is, and not just for packaging, but for parts. What was the cause, and then how will it be resolved, and how will they make sure it doesn't happen again? And they're scored on not just how many defects they have, but how they respond and have they resolved these defects. So they have a scorecard. I mentioned before that typically more than one rack supplier is used by the OEMs. Now, if you're a tier, I've seen tiers where they only have one supplier for a rack for any particular part, because their volumes aren't necessarily as big, so they don't have to go through that. But if you're an OEM, or if you're making a part that has a high volume and there's not one supplier that can handle it, then they'll look at what the capability is. Now, we don't see this as much as we used to. Purchasing goes in phases on their approach. So like I said, they might have the online bidding, they might have, in face-to-face bidding with everyone there. They may have bidding with, who else is bidding. It just kind of depends on the company and the time. But one of the things that you want to look at is, what these fabricators, what their capacity is. So this kind of gives you some examples on, how you might break it up. So, this one, these first three can make 1,000 racks per week, and then the last two can make basically 800 together. So you're looking at just under 4,000 racks per week. They need 33,000 racks. So based on, 4,000 racks a week, you're looking at, I don't know, just under 9 weeks, roughly. About 9 weeks is going to take to build all these racks. But they also look at, they don't want to take up their whole capacity for a couple reasons. If something were to happen, they shut down, it's going to really impact how many they can receive. Another reason is that they might be building other racks at the time. So even though they can build, like fabricator A can make 1,000, that's their maximum production rate. So it's probably easy to say for fabricator A, give me 300 a week, because then that means that if they have any issues, they will have time to make up and get those 300 per week to them. Plus, if they're building for anyone else, they don't have to really adjust their schedule and stop giving racks to someone else, or even that same day, maybe they're supplying 3 different racks to you. You don't want to tell them, okay, we need 200 of these racks and 200 of those racks and 500 of these racks. Oh, and another 200 of those. So now you're over 1,000 racks. So you're actually, you've maxed out their capacity. So you want to keep track of, what they're capable of building in general, but then you also want to make sure that you're giving them just a fraction. So these are some calculations that you want to look at. And it tells you, how they get to this. So basically, we know that you're looking at 33,000 racks. And when you look at how many you're going to build, when you take the 30%, you're looking at 1,140 racks per week when you add these all up. So now you're trying to figure out, okay, I have 33,000 racks that are needed. I can only get 1,140 per week from all 5 of my suppliers. So then you're going to come out, it's going to take 29 weeks. So it's going to take 7-8 weeks to do this easily. I'm sorry, 7 or 8 months to get this done. I'm sorry. And then you want to make sure that they have their production schedule set. Because, at the OEM, if the OEM isn't setting their production schedule, and then maybe they have a bump in production and they're making 1,100 a week, but they need more, it's going to be really hard to get that. So you also want to make sure that this ties in with whatever production you have, either at the OEM or the tier, wherever you're working. So based on how long it's going to take, this particular example, you're looking at production starting at the rack supplier in phases 2 and 3. So again, we'll go back up here. Phase 2 and 3, this is where they're making fewer than 200 vehicles here, right? And in phase 3, they're still doing 200 vehicles that aren't for sale. So they're already starting to build racks, which means that at phase 3, you want to know which parts are, what needs to be protected, especially for the ones that are going to go in racks. And this would also go for things that maybe require tooling that will take, has a long lead time. So you want to keep that in mind. So as you look at your schedule, you also want to back into, anything like a rack or anything that requires tooling that may take months to get. How does that look? When do I actually need to start ordering that to meet production starting in phase 4? And you will get, and I'll see if I have any, you'll get, like, a lot of times they'll have Gantt charts. And these Gantt charts is basically looks like a spreadsheet, and it has a calendar on it. It will show for certain weeks, when they plan to do budgeting, when they plan to do their first test, when they plan to have suppliers all decided and sourced, when they plan to do the next round of testing, when they plan to launch, full scale production, all those sorts of things that they will be on this Gantt chart, which basically is a timeline. It's a combination of a spreadsheet. It looks like a spreadsheet, but it's got a timeline on it. So you want to look at that and back out from that date from production. When do I need to have packaging there? Okay, if I know it's going to take me 30 weeks to get a certain package, then you need to say, I need to start, if we're going to start on January 1, I need to go back 30 weeks from January 1 to start getting this packaging kicked off, approved, made, those sorts of things. So just keep those things in mind. Okay, so here we go. Standard containers. We started talking about this last week. We talked about the standard containers, but we didn't talk about what it would take to make modifications. So a standard container that's modified would be something like a bulk bin that maybe gets cut open on one side, as you see the fork entry, and it's used, it has maybe some cells put in it so that parts can be transported and protected. So we'll pretend that this one is the fork tines are here in the building, something like this. So rather than shipping the parts like this, where they're touching each other, let's say they can't touch each other and they can't wiggle. If you build a modified container, because they also might be large parts, you can protect them, you can separate them, and they can also be easy for the operator to grab. So when you saw that video for the Ford Rouge plant and you saw a lot of where the operators were working, something like this could go, sorry. Something like this could go on a table that is, you could have a table underneath it that's a hydraulic lift table or turntable. Something like this, if it has a lift on it, then as it's lifted, let's say the operator is, this is his or her reach right here. When they empty these out, they have that lift table lift that up. So now the operator can reach these two levels. And then when these are empty, the operator can use that lift table to lift it even higher up. So instead of reaching down to this lower level, they can raise this whole container on the lift table so that this bottom row is now at their arm or shoulder or waist level, so they can reach it. So the idea would be that between here and here is going to be between your shoulder and your waist for reach. So the arm goes straight out and you're not reaching up or down, or you're not bending. So I mentioned again that you might have 60 different designs for a new program. To do a design like this, it can cost $6,000 for each design. So if you've got 60 of these designs and you're paying $6,000 per design, now you're looking at spending $360,000. So go back up here and we can talk about the racks. So now we spent $720,000. See if that works. Why this isn't working? $720,000 just for the design of the racks. Okay, that doesn't count the cost, the actual cost of the $1,500 per rack times the number of racks needed. So just for the design, you're paying $750,000. And then you go to, okay, I'm not sure why this is doing this. Very annoying. Okay, so now we go to the standard containers, right? And just for the design alone, you're paying another $360,000. So now we talked about $250,000 plus $360,000 just for designs for two different types of packs. We've got all your racks and all of your modified standard containers. So this container can easily cost, something like this can cost about $750, probably more like $1,000 now. But the container itself, this row pack used to cost about $150. Not sure how much that's changed because row pack or Orbis, they tend to keep their prices even during the pandemic. So I'd have to do a little research and find out how far off that is. But I haven't heard of any major increases with those. But this is just a round number for budgeting. So you could say that just the plain row pack by itself without modifications, say it's $150. And then you add all the dunnage that's required. This is corrugated plastic. This is like a cloth. And also in here, you have metal bars because these can slide. And then this is sewn. And then it is attached inside of here. It could be riveted. Many times I use rivets. This one It's also affixed probably with rivets. So when you look at all of the different things that are needed for this, you're going to spend easily another $600 just for this interior dunnage to go in here and to have it installed or built into it. So just these containers, that's going to be another 10 to $15 million. So we spent somewhere between 35 and 50. Let's just go on the high side. Let's say we spent 50 million for racks, and then we spend another 15 million for your modified standard containers. Now, it adds up pretty quickly, right? Okay. So if you get standard containers, we were talking about the whole process of prototypes, and I mentioned that if you have things that are either already being used and you're just reusing, or you have standard containers, you don't have to necessarily look at getting prototypes. So the prototype cost for the standard containers is gone, because you already know you can, if you want to test something, you probably can grab an existing bin and use it for a trial, instead of getting a special prototype made and testing it and then modifying it and getting drawings for it. You're just using a standard pack that already has a drawing. You already know the size. You can grab something like that off the floor and use it for a test. But for an OEM, for a new program, you can easily spend another $5 to $7 million. So now we're adding the 7 plus the 15, we got 22 million plus another 50. So we're looking at over $70 million just for those 3 categories of packaging, right? So plus all of the costs for the design. Then there are other costs. You've got dunnage, for example. So all of these, you could have these shipped empty, but then you may have special parts that require dunnage, because parts need to be separated. The parts can be damaged easily. You have parts that maybe are sensitive to electrostatic discharge. So you might put them in an ESD bag, or you might use ESD foam, the pink foam. So, these are some of the things. What are some of the things that are needed? Do you need simple dunnage like that, or do you need to have dunnage that is designed specifically for your part? So, you need something like this that actually fits in your bin and holds the part, or something fits in your tote. So, those are other things that you need to add in, would be the cost for dunnage. And some of that dunnage requires special tooling. So you could have, trays that are injection molded that require special tooling. Or some of this foam, depending on how your foam is made, you may need tooling or fixtures for that foam. And then if you have racks, you may have, this isn't a good example. This one is going to have soft dunnage, right? And these move up and down to get out of the way if you need to. But they've got wire or steel rods. But then some of the racks will have dunnage that is made of, rubberized plastic that will keep the part from rubbing up against. So you might have metal on metal for some of these parts, or you might have rubber for glass. It's holding the glass, but it also provides some protection from vibration. It keeps the glass from breaking. Okay. So when we talk about the material handling equipment, these are some of the things that I pointed out, and I'm sure you noticed in the Ford Rouge video. We've got carts and tuggers and fork trucks, and even some of the equipment lifts, those assisted lifts that they were pulling the parts and putting them, so they might take it out of a pack and put it in. Sometimes they may need some of that to help move packaging around. And get the part in there. So there are a lot of different uses that are needed for material handling equipment. So, we have the scissor lifts, we have lift tables. I showed you all the different ones last week for all the different designs. Fork trucks and tuggers, they have requirements for repairs, preventive maintenance. One plant that I worked in, we had fork trucks. They would put governors on the trucks so that the trucks could only go about 3 to 5 miles per hour. But the fork truck drivers would get frustrated with it, and they would turn off the governors. They figured out how to go in and turn them off, so then they could drive the tuggers faster or drive the fork trucks faster. And then the maintenance team would have to go back in and reset all the governors to slow this down. So this would be an example of cost to have maintenance people keep checking to make sure that this equipment is safe. Mentioned about the testing. So an example would be with the racks, where the racks need to be tested to make sure that they don't break off if someone drags them across the top of the door. Also, if you have a rack that is going to go by rail, are they going to be able to withstand the rail vibration or truck vibration? And not just for racks, all the designs, you have to do transport testing on the packaging. If it's new, if you find that the product is vulnerable and needs to be protected by packaging, those are some of the things that you do. So it's important. That's another reason why it's important to have a parts list. And with that parts list, understand what those supply chains are, because that will help you determine what type of packaging that you need. Besides, once it gets inside and how it's handled from a line side standpoint, you also want to know how it's going to be transported. And that would go into your test sequence. And then this talks about program management costs for racks programs that being either managed by the OEM or a third party. So when I worked for, it was an OEM, but we supplied, it was a strange setup, because we were part of the OEM, but we supplied to the OEM. So we were tier 1 for the assembly plant. Even though we were part of the OEM company, we really basically, if we had been a different company, we would have been a tier 1. So we managed the racks, and we had an issue with new fork truck drivers breaking the tops of the racks off because they kept running through doors and going into trucks. And so they would tear the post off the racks, but then they would also tear the doors on the trucks because they were loading those racks. They were lifting them too high. So as they went into the truck, they would, the tops of the rack would hit the top of the truck, and it would damage the doors on the trucks. And then once those posts were hit and they were loose, they weren't strong enough to hold another rack on top of it. So sometimes they would come and they wouldn't see it, and they would stack. They would come back empty. They would stack them on top of each other. So there was weight, but not that much weight. But then when these racks were put on the automatic conveyor and the racks were loaded, and then when they took that rack off the conveyor, when it was full of racks, and then took it and started stacking them to be ready for transport, and they would stack those racks, they'd stack them high enough so that they'd have the one stack that they could put right in a truck for speed. Those racks would not hold the engines. So, those are some of the things that you have to keep in mind. We had to institute a rack repair process. So we had to, if we saw racks, so I had to put together like a whole standard work on if the racks were visibly damaged, they were missing parts, they needed to go into a certain area. If if they found any certain things on the rack, they would go in a different area. If the racks looked okay, but when they started using them, they were obviously weak, they'd go into a different section. So that would, because that was based on different types of repairs that were needed. So then we had a repair company come in, and they would either repair them on site if it was easily fixed, because they couldn't have like welding equipment on site. So if they required welding, they would have to take them with them to their facility, fix them, and then bring them back. And then we'd have to keep track of how many were in repair, how many were in the repair loop, because then we didn't ever want to run short on racks. So that would be an example of managing the repair program. And then we had also containers that would maybe get dirty. So you have plastic totes or bins that they were using some standard totes, so they could get used for a multitude of parts. But some of the parts that came in maybe were oily, but then other parts that came in could get oily. So if they were to take these totes and send oily used totes to a supplier that couldn't have oil on their parts, that was an issue. So we had to determine, do we wash everything, and do we inspect everything? Do we keep track of the ones that we know will be oily and wash them, or have someone else wash them? So, those are some of the things that you have to look at. How do you repair and keep these containers clean? So again, we go through all this. If you start talking about things of designing, prototyping, testing, managing all that, it could be anywhere between $1 million and $2 million for cost for any OEM. Then when you start looking at the cost to make racks, you're looking at, again, a $30 to $50 million, plus another 10 to 15 for modified containers. This is just summarizing what we talked about. So, you're looking anywhere from $50 million to $72 million just to buy your containers, right? These are some of the things that you are looking at based on expense, ways you can save money as you're looking at what type of container we need, how many do we need. Can you use a modified standard container, which is going to be more cost effective than a rack? Because that could make your cost half of what it originally was. Another thing that's really popular with racks is reusing the racks. So that rack frame, so you have the base and you have 4 corner posts on it. And they, a lot of times companies will look at, can we just reuse the rack, which would mean keep those same corner posts, we keep the frame, but the interior of the rack that's holding parts, then we can modify that and use it for something else. So they might have certain sizes of racks and say, okay, this rack, every time we use windshields for a program, the windshields for trucks are going to generally be about 60 inches. I'm just making this up. So we know that our windshields are generally in a standard range. So our windshield racks are going to pretty much be in the standard range, and we can reuse those, change whatever dunnage we need to adjust for the curve or the difference in length or the slight difference in height. But in general, they're going to be, within 6 inches of the dimensions of the last one. So can we reuse these? Can they reuse component parts? So, things like our gates or arms, posts on the racks. So this is where it's important for maintenance. If you maintain your racks really well, the more the racks are maintained, the better you can reuse things and repurpose these racks. Tooling. So again, depending on what tooling you get, if you get something that's basic tooling, could be $10,000. If you get something that is very complex tooling or larger volumes, it could be up to $100,000. So can you look at, the dunnage that you're making? Can you use the same dunnage? So an example would be for the racks, and if you're using windshields, can you use the same, rubber tips, which would be dunnage? Can you use the same rubber tips for different windshields? Can you take the ones off of an old rack and put them on a new rack? are you gonna, you might have a part that you use foam. Can you use the same foam tooling from one program to the other? Are the parts similar enough where the tool that's needed can use the same thing? A lot of times you'll see it with like thermoform trays. They may use the same footprint, but then they'll have different inserts. So the tooling for the mold, whether it's like thermoformed or injection molded, they might use the same main tool, but then they put in inserts so that you have, differences in what that tray looks like. And can you also modify it? You might be able to make some minor modifications to that. The tooling, the products or the packaging is done into similar enough that you can use the same tooling and just modify it, or do you need all new tooling? Okay, so here's some examples of arms. Maybe you want to reuse some of the arms. This is dunnage. I'm going to try this again. I think my vanishing pen is white. Okay, right here, right? This would be examples of, that's an example of dunnage. These are examples of dunnage here as well. So you've got your arms here, but then you have dunnage as well. Any questions right now?
Nope.
Okay, so here's a fun end of life. So when you have all these racks, like I mentioned before, sometimes you'll drive over, if you're in Detroit and you drive over an overpass and if on a freeway, you might see a bunch of racks sitting up there. That's usually because the racks, the program ended, they're not making that vehicle anymore. They didn't repurpose the racks, they didn't reuse it for whatever reason, and they just never threw them away, because then when they do that, that is something that they have to put in on the books from an accounting standpoint, that they got rid of these. They no longer have this asset, and it can have tax implications. And sometimes the finance and the accounting team don't want to do that, so they'll hold on to them. So what do they do with them? So one, they could just, set them aside. They could throw them away, but many times they do try to reuse those racks, and they try to reuse not just racks, but containers. If they can take a bin or a tote and they can, take out the dunnage and replace the dunnage with something else, then they'll do that. I mentioned they might use gates or dunnage or arms for racks. They might try to use, maybe they can use some of these again and maybe make some modifications. So it just depends. They just look to see, can we reuse any of these? Can we recycle? So steel, can they sell the steel? The other thing is plastic. Can they reuse the plastic? Can they grind it up and then can they use it for scrap? One thing to keep in mind is, I don't know about other states, but in Michigan, stealing containers is a felony. So I want to bring that up. That is a felony. And I mentioned before that some companies might take containers and resell them. There have been organized crime circles that have figured out that if we have a container and it's obviously stolen, we could be prosecuted for it. It's a felony. However, if you find just the scrap plastic, it's not considered a felony. So, because you can't really trace it and know where it came from. So there have been some organized crime rings that I've heard about that will put grinders in the back of the truck. And as they get these containers, they just grind them up into the truck. So they don't even go into the truck as containers, they go in as scrap. So they just look like scrap recyclers. But you can, as an OEM or as a tier, you can get your plastic and your steel recycled. Um, I mentioned about racks and containers that can be sent off to an offsite storage facility. Sometimes they might do this if they say, one, a finance or accounting doesn't want to write them off yet as an asset because it will cost too much money on the books. The other one is that maybe they want to set them aside because they say, hey, we're going to reuse these racks or containers in the future. So we're going to set them aside and hold them for when we need them. So now might have, warehousing and storage costs that are involved. And you want to determine, is it cheaper to store these? You're going to pay 100,000. I'm just going to throw out a number. You're going to save 100,000. You're going to spend $100,000 to store these because maybe that's cheaper than spending a couple $1,000,000 to buy all brand new ones when these were perfectly useful. I mentioned here, suppliers and assembly plants always have to get financial approval from the OEM before disposing of corporate assets, because depending on the program, depending on how things are set up, sometimes the OEM, if the packaging is shipping into the OEM will buy it. However, the tier is responsible for making sure that the packaging doesn't get damaged, making sure the packaging is clean, making sure the packaging doesn't get lost. So the further for each tier supplier to an OEM or tier, they could be responsible that whoever's supplying could be responsible for paying for replacement of lost containers. But if the program is done and they're not using it, they still need to call, hey, OEM, we've got your containers here. What do you want us to do with them? And if they say, oh, just scrap them, just throw them away, or send them back to us. Or they say, we've got these containers, we could scrap them if you want, or we can use them for something else. They have to get approval. The OEM has to say, okay, because when the OEM says, okay, from a financial standpoint, then that means that they've written them off their books. So from an accounting standpoint, it shows that they're gone, they've disappeared. They've used up the entire life, they've amortized these assets, whatever it is that they need to do. So it shows no longer on their books as an asset or as a loss, however they have it on their books. Okay, look at the time. I'll start to dig in here a little bit, but we're pretty close to time here. So I think I'm gonna on the next lecture tomorrow for lecture 5, I'm gonna get into some of the requirements for manufacturing. But I've been kind of talking about this already. You've heard me talk about things like lean manufacturing and how important it is for the material to be near the operator. I think I even mentioned what was called the strike zone, which is a term that's used to say this is the ideal space for the operator to work. So if the operator is working, it would be the same as striking a baseball. And if they miss, because the umpire has deemed that this is a comfortable level for you to hit the ball, you should have been able to hit the ball. That's really the working space that is considered to be comfortable and ergonomic for an operator. And ideally they can work very quickly and they maybe don't have too much repetitive motion, they don't have too much reach, they're not bending, they're sitting in a, they're standing in a really good position. So they're stable and they're able to work pretty quickly. So those things come in to play here. So I'll talk about some of these things. Things like the heavy lifting and pushing. You saw that in the video with Fort Rouge, where the operator had a lift assist, where he took that whole assembly, he could move it, wasn't really bending a whole lot, he could just push it right into the vehicle. And I don't know if you noticed that, but he could almost stand in one space and put that heavy assembly in. So, those are some of the things that you want to look at when you're designing packaging. It's important to understand how the parts are designed and how they are meant to be assembled into the vehicle, because a lot of thought actually goes into that. You see how, again, that example where the guy took the lift assist and put the whole assembly into the front of of that truck, a lot of thought went into that. Which parts need to be in that assembly? Um, you know, how are they sitting? So when he does install it, he just torqued in a few screws. He didn't do a full assembly. So at some point, someone else is going in and they are fixing that assembly to, securely to the vehicle. But there is a reason for that. They could have said, okay, we're going to make him secured all the way physically at that point. But they said, no, at this point, there are a few other things that have to happen before that whole assembly should get secured. So that happens for the parts, but it's important that you think about those things when you start designing your packaging. What type of parts are being pulled, where do they get pulled from, how much do they weigh? A lot of those things are really important. So I will talk about that tomorrow. You can see here, this is similar to what we saw in the video where the guy had a lift assist. One of the reasons why this is important is because this has to be packed somehow. So when it's packed, you need to understand how it's going to be handled to go into the vehicle, or how it's going to be handled to be assembled. Because if you have a large assembly like this and it's going into, say, a rack, you have to know where that lift assist is picking up the part so that lift assist doesn't interfere with the rack, for example. Or if you have an assembly that's being put together at a tier before it comes over to your assembly plant, to the OEM, it will obviously have to get lifted into the packaging before it gets shipped out. So you have to look to see, how can it be put into the packaging? Maybe sometimes some things might be built in the packaging where they're gonna drop it into the packaging with the lift assist. It's really hard to say. And then sometimes some of this might be manual. The tiers may not have all the equipment that the OEMs have. So where something like this might use a lift assist at the OEM, it's important to understand that the tier 1, is that going to be handled with the lift assist as well? Or will it be handled, will they have 2 or 3 people lifting that and putting it in? Which is going to be more common if something like this part is coming from overseas. So it's important to know those things, that as you sign off on packaging, because a lot of the packaging, you might be looking at and signing off on it, but their suppliers may be making it. But you have to keep in mind, okay, well, this is designed for lift assist at my plant, but on their end, they may not be able to pack it into that same pack because they're doing it by hand. So, those are just some of the things that you have to keep in mind. Because I'll go into more of this tomorrow, but this talks about ergonomics. This is that strike zone that I talked about. The operator is working. One thing to notice as I talk about the strike zone in the OEM at the automobile assembly plant, you'll notice that going down the line, the racks are usually behind them or to their side, but in some of the tiers, there are a lot of parts that are loaded. The packaging is right in front of them and they're pulling it and then they're just assembling it right in front of them. They're not turning or anything. So those are some of the things to keep in mind. How much turning is there? How much bending is there? Can your packaging resolve some of that? Or is your packaging going to make it more difficult for either packing at the tier or unpacking at the OEM? Okay, so again, tomorrow I will start here on manufacturing requirements. I know the homework was turned in. I'm going through and checking it. I will continue to check it and have it by the end of the week. If you have any questions, let me know as you go through this. Brandon, did you have any questions for me? Do you have a few more minutes?
Nope.
No? So what is your impression on some of this?
I'm definitely seeing this as a lot more content heavy, number heavy. So it's gonna be an interesting read after the lecture as well.
Yeah, I was trying to give some examples as we go through it,
Hmm.
but it's really important that you kind of understand everything that's going on. It's so interesting to me that I'm going through this today because right before I did this film, I was talking to a client of mine. They're looking at building a greenfield or from the ground up facility for part of their assembly. And they were asking me, what's the packaging? And I said, well, I need the parts list. I don't even know what you're making to go through here. So,
Right.
they have someone that's working on the packaging, and they had one tray. They're trying to use a universal tray. So it's the same size, same footprint, but they had 9 pieces in one, I think 6 pieces in the other, and then maybe 12 pieces in the third one. So I'm looking at it and I'm thinking, well, that doesn't multiply by anything. Like if they go to order, if they go to order the 6 or the 12, they could order in multiples of 12 or 24. But then the other one that's 9, what do you do?
Right.
Because if you say 9 by 6, you've got 50, you've got to order in sets of 54. But if they're only making like 30 a day, now you're going to have a day and a half of material on the line in front of you in order to, or they need to put it in the back. And now they need extra warehouse space for all this material. So, if they're trying to keep a day's worth of material, but now they're going to get in a day and a half every time they order, so I'm trying to first get a list of all the packaging of all the parts so I can look at the packaging, but then also encourage them that all these things need to be multiples of each other so that they can all be brought out to the line. So like the tugger driver that you saw in the forward video, the tugger driver can just go pick up, 2 of these and 3 of these and 4 of these, and they all deliver at the same time versus I got 2 of these and 3 of these and 4 of these, but now I got to go back and get 2 more of these in an hour and a half to make sure they match, and things are going to be off.
Yeah, makes sense. Makes sense.
Yeah. So basically hot dogs and hot dog buns. Hot dog, basically. Yeah.
That's a good one.
Yeah. You'll see what I'm talking about. So yeah, so that's pretty much it for today. Let me know, anybody, if you have questions. Again, I'm going to try to film these every day, short of some mic issue with Zoom. I'll plan to get those out as soon as I can. I found, I thought that it would take maybe less than an hour to get these posted, but with that, for some reason, I don't know what it was with that one video. I don't know if I said something I shouldn't have said. I don't know. I'm just kidding. But it took hours for that thing to download. And then when it did download, there was no sound. So I don't know what it was about that particular video. But my goal is to get these posted, within an hour or 2 max. So if they're not posted in like 2 hours, there's usually something going on, is what I'm already noticing.
Gotcha.
But yeah, so thank you for joining. And I will talk to you soon.
All righty. Peace.
All right. Bye-bye.